Now that we've seen how parts are created in Solidworks, let's take a look at how we can combine them together to create an assembly. Creating an assembly makes a lot of sense because we can test our parts for form, fit, and function, as well as try to identify problems in the 3D environment before we have our parts manufactured. We can also simulate motion and mechanisms by using constraints or relationships called mates to limit the degrees of freedom with which parts can move in the assembly environment. There are two main philosophies for creating assemblies. They're called bottom-up design and top-down design. Bottom-up design is an approach wherein you create all of your parts first as individual components and then assemble them together using mates to create the final assembly. Top-down design, on the other hand, is a little more complex. This approach involves creating a layout inside of an assembly and then designing parts within the context of the assembly, or, in other words, within the assembly environment. We won't be covering top-down design in this course, but instead, we'll be utilizing the bottom-up design approach and building this wheel assembly by piecing together parts that we've already created. There are several ways to start a new assembly in Solidworks. Right now, I have the bracket part file open that I designed earlier. To create an assembly from this part, I can either go to the File drop-down menu and select New to bring up the New Solidworks document window, choose Assembly, and simply click OK. But to show you another way, I'll go ahead and click Cancel. I can also click on the File New icon to bring up the same dialog and choose Assembly. Or from the File drop-down menu, I can choose to make an assembly from this part. And I have the option of choosing this option when I expand the File New options as well. All four of the options will bring us to the blank assembly file like you see here. On the left, you can see the Begin Assembly Property Manager that appears. Here, I have an option to either insert a component or create a layout sketch. Creating a layout sketch would be useful for top-down design when you want to design components in the context of the assembly. However, as I mentioned earlier, I'll be using bottom-up design. So instead of starting with a layout sketch or blocks, I'll instead choose a component to insert. Here in this list, you can see all the different part files that I have open in Solidworks. I can also use the Browse button to browse for a part file on my hard drive or on a server location. For this lesson, I'd like to use the bracket component. If I expand the thumbnail preview, you can see a preview of the bracket component to make sure that I'm starting with the correct component. And I also have the option to show a graphical preview. I'll check this option, and when I drag my cursor into the graphics area, you can see the part appears in the assembly. I can click anywhere to simply place the part, but there are a few things to consider before doing so. Let me use the Hide and Show drop-down menu to show the origins. Notice that there is a separate assembly origin and part origin here. Now, if I clicked here and placed this component at this exact location, the part origin and the assembly origin would be different. In some cases, you want this to happen, but most of the time, I find that when starting an assembly, aligning the origin of the first component that you place with the assembly origin is beneficial. That way, the reference planes of the assembly are aligned with the reference planes of the part, which helps you predict and determine the center of mass and orientation. If I hover my cursor over the assembly origin, notice that the part snaps into place. I can click here, and the part would be placed with the origin of the part perfectly aligned with the assembly origin. Another way to have the origins aligned automatically is to simply click the green check. This is my favorite method, because you can see that the origin of the part and the origin of the assembly are in the exact same place. Once the component is added, you can see in the assembly tree that the part file was added along with the default reference planes for the assembly and the assembly origin. Now that we have our first component located in the assembly, let's take a look at a couple ways to insert additional components. Solidworks is very flexible with the ways that you can insert components into an assembly, so there's a lot of different ways to do it. One way to insert components is to use the Insert Component tool found in the Assembly tab of the Command Manager. When I select it, the Insert Component Property Manager appears, and you can see it looks very similar to the Begin Assembly Property Manager that we saw in the previous lesson. From here, I can use the Browse button to browse for parts on my hard drive, or you can choose an open part file such as the wheel from the list of open documents, and simply click in the graphics area to insert that component. Here you can see that the wheel has been inserted into the assembly, and it appears in the assembly tree. I can also insert multiple parts at once. To do this, I'll select the Insert Component icon again. When the Property Manager appears, I'll hold down the Control key and select the pin and the bracket. Then, I'll go ahead and drop them one by one in the graphics area. Now, all the components have been inserted into the assembly. I'll go ahead and click Undo until I have the bracket left. Another method is to tile your windows so that the component you want to insert is also visible. For instance, this pin component here. I can select the pin component from the Feature Manager tree and drag and drop it into the assembly. And when I let go of the mouse, you can see the pin component has been added to the assembly. Again, I'll click the Undo button to remove the pin component again. For the final method, you can drag and drop components in straight from Windows Explorer. Here, I have a folder that contains my part files in Windows. I can select the wheel component and drag and drop it straight from Windows into the assembly. And I can repeat the process for the pin component. And those are the different ways to add a component into an assembly. Now that we've seen how to insert components into an assembly, how do we locate them? Solidworks makes it pretty easy to move and rotate components anywhere within the assembly environment. To move a component, you can simply select it and click and drag it with the left mouse button. And where you release the mouse button in the graphics area is where the component will be moved to. You can zoom using the middle mouse wheel like in the part environment, and you can use the right mouse button to rotate. So you can click and drag the left mouse button to move. You can rotate the entire assembly by holding down the middle mouse button, and you can hold the right mouse button to rotate an individual component. Another way to move components is by using the Move Component tool. You can find the Move Components tool on the Assembly tab of the Command Manager. When I select it, the Move Component Property Manager appears. There are a couple options, but the option I'd like to show you here is the standard drag. To use the standard drag, you simply select a component, and with the left mouse button, click and drag. There are a couple additional options which can be useful for design validation, such as collision detection and physical dynamics, but these are beyond the scope of this course. If you expand the Rotate dropdown, you have the option to rotate either about an entity using a coordinate system or free drag. With the free drag option selected, I can rotate the part simply by clicking on it with the left mouse button and rotating it in the graphics area. However, notice that when I try to move the bracket, a message appears telling me that the selected component is fixed and cannot be moved. Why is that? I can move the other two components, but I can't move or rotate the bracket component at all. If I hit Escape and look in the assembly tree, you can see there's a little F next to the bracket component. The letter F indicates that the component is fixed in space. By default, in Solidworks, the first component you insert into an assembly is fixed. This is done for a variety of reasons, but mainly because it provides a datum or a frame of reference to which you can mate other components to. Think of it like the chassis of a car. It's the one component that will remain stationary while the rest of the parts are added and built around it. If for any reason you decide later on that you need to move the bracket component, you can simply right-click it and select Float from the right-click menu. You can now see that the F is replaced by a minus sign, like the other two components, indicating that it's floating, underdefined, or free to move. You can then move it in the graphics area. I'll hit Undo to move the bracket back to the origin, and right-click it to fix it again. You've seen several ways that you can move and rotate components within the assembly environment to help define their position or help locate them. But when I am moving these components around on the screen, I'm not actually defining their position at all. I am simply moving them in the graphics area. To fully define the position of a component in an assembly, you have to use something called a mate. You can think of mates as the 3D equivalent to sketch relations that I showed you when in the sketching section of this course, such as coincident, concentric, tangent, etc. The difference is that mates allow you to create a relationship between the 3D geometry of the components in your assemblies. Fortunately, mates are very easy to use. Here, I'd like to center the wheel and locate it in the bracket. Adding a mate is a two-step process. First, you must select the items you want to mate, and then choose the type of mate to apply. There are several ways you can access the mate command in SolidWorks. One way is by clicking the mate icon from the assembly toolbar on the command manager to bring up the mate property manager. In the mate selections box, you can select whatever geometry you would like to mate, such as edges, faces, vertices, or reference planes. Then below, you can select the type of mate you would like to create, such as a coincident mate, concentric mate, as well as a few other more advanced mates that I won't go into in this course. We will take a look at most of the standard mates. These are the ones that are most commonly used. Now, rather than accessing the mate command from the command manager, a slightly more efficient way of adding standard mates in an assembly is to do so right from the context toolbar, which is similar to adding sketch relations in a sketch. To show you, let me exit out of the mate property manager. I will select the interface of the wheel, and holding down the control key on the keyboard, I'll simply select one of the inner cylindrical faces of the bracket. When I release the control key, the context toolbar appears. Here, you can see a list of all the possible geometric relations that exist between the two entities I selected, such as parallel, perpendicular, and distance. You can also see the default mate type is highlighted. In this case, the concentric mate is the mate type that I want. I'll go ahead and click it. When I do, the mate is added and appears in the mates folder. When I click the wheel component now and try to move it and drag it, notice I can only move it from side to side. I can no longer move it up and down. The wheel is still free to spin and free to move, but its degrees of freedom have been significantly reduced by just adding that single mate alone. Now, how can I center the wheel onto the bracket? Well, I just need to create an additional mate. This time, I'll select the inside face of the bracket and the outer face of the wheel. Again, you can see the in-context toolbar pops up, and the default mate type for these entities is coincident. When I select the coincident mate, notice that it will make it so that the two faces that I selected are touching one another. Since I want to center the wheel, I can delete the coincident mate I just created, and then create a distance mate between the entities. But instead, I'd like to show you how you can edit existing mates. To do this, from the feature tree, I'll select the mate that was just added, and from the pop-up, I'll select Edit Feature. The Property Manager appears, and you can see a list of the geometry that's being mated together here in this selection box, and you can also see the geometry highlighted in the graphics area. Under Standard Mates, I can change the type of mate that is being applied between the selected entities. Parallel would make the selected faces parallel, and perpendicular gives me an error, since in order to solve such that these faces are perpendicular, it would violate or conflict with the concentric mate that I added earlier. To center the wheel, one approach would be to add a distance mate, which will allow me to enter a distance value between the two faces. In this case, since I already know the width of these components, I know that the value to center the wheel is 0.195 inches. So I can type in the value, and you can see that the wheel and bracket shift to solve for that value. As you add mates to your designs, it is important to think about the design intent that you are building into the model as you do so. What I mean is, although the distance mate here does, in fact, center the wheel within the bracket as it stands right now, what would happen if the width of the bracket were to ever change down the road? If that were to happen, the wheel would no longer be centered, since the distance between these two faces would no longer be accurate for centering the wheel. Let me show you a slightly more robust approach to centering the wheel here. I'll clear these selections by right-clicking in the selection box and press Clear Selections. At the beginning of this lesson, I mentioned how mates can be applied to edges, faces, vertices, or reference planes. Now, I happen to know that the way these parts were designed, they each have a default reference plane that passes directly through the center of each part. In fact, it was an element of design intent that I considered when designing each component. To select the default reference planes, I must do so from the Feature Manager design tree. Normally, the feature tree appears here on the left-hand side of the screen, but since the Mate Property Manager is currently taking up that space on the screen, I can expand the feature tree from the upper left corner of the graphics area, and here, I can expand each component. I'll select the front plane of the bracket and the right plane of the wheel. Since both of those planes pass through the center of each component, I can use a coincident mate between them, ensuring that the wheel will always be centered about the bracket. I'll click the green check to accept the change to this mate, and notice the Property Manager stays pinned on the screen in case I had any additional mates to add. I'll click on the red X to exit the Mate Property Manager. Notice now, I can no longer move the wheel side to side, but it is still free to spin. If I wanted to prevent the wheel from spinning, there are a few ways to do that using mates as well. One way to do this is to edit this concentric mate I added earlier. And notice, there's a checkbox available to lock the rotation. I'll mark the checkbox and click OK to make the changes. And I'll click the red X again to exit out of the Property Manager. Now when I try to rotate the wheel, notice it doesn't move. In the feature tree, you'll see that locked concentric mates are indicated by the filled-in blue center of the concentric icon in the mates folder. Let me show you one more way to prevent the rotation. I'll unlock the rotation of this mate by right-clicking it in the feature tree and selecting Unlock Rotation. This time, I'll use the Mate Property Manager by clicking the mate icon. For my selections, I'll again expand the Feature Manager tree and expand the wheel component. Since both the front and top planes pass directly through the center of the part, I can select either of them. And for my second selection, I'll just select the top face of the bracket. When I do, notice the parallel mate type is automatically activated, and to apply it, I can just click the green check, and click the green check once more to dismiss the Property Manager. Now notice, when I try to move the component, I'm greeted with a message saying the selected component is fully defined and cannot be moved. Also notice, in the feature tree, that the minus sign next to the component has disappeared. There is no F there as well, just the minus sign is gone. This means that the component is not fixed like the first component of the assembly, but all degrees of freedom have been removed based on the mates that have been applied. To get rid of an existing mate, you can of course select it from the feature tree and press delete on the keyboard, but that would permanently remove the mate from the model. Another approach is to just suppress the mate. If I click on the parallel mate in the feature tree, from the pop-up, I can choose Suppress. When I do, notice the wheel is again free to rotate, and the minus sign now appears next to the wheel component in the tree, indicating that it now has some degree of freedom. The parallel mate is still listed in the mates folder, but it is grayed out. The ability to suppress mates is a really nice feature to have because it allows you to lock and unlock certain degrees of freedom without having to create mates over from scratch. If you have lots of mates, it can be a good idea to rename them so that you know exactly what you are mating. You can do this easily by slowly double-clicking on the mate and typing in the new name. I'll call this mate lock wheel rotation. And that's how easy it is to add mates. Now that we've centered the position of the wheel using mates, let's go ahead and add mates to the pin component to define its position as well. Mates are just like relations, and you can define them in a lot of different ways based on your design intent. In this instance, for this pin component, the first thing I'll do is select the outer cylindrical face of the pin, and while holding the control key on the keyboard, I will select the outer flat face of the bracket. When creating mates, you should obviously be aware of what you select because the items you select are what get mated together. If you select a face, Solidworks will mate the face, and if you select an edge, it will mate the edge. If for any reason you make an incorrect selection, you can deselect an entity by holding down the control key, select it again in the graphics area, and then simply select the new geometry. When I release the control key, the context toolbar updates with the mates that are possible between the selections. From the context toolbar, I'll choose concentric. In case the orientation of the mate is going in the wrong direction, you can always right-click the mate from the mates folder in the feature tree and select Flip Mate Alignment. Let's take a look at what this concentric mate does. The pin is aligned correctly with the holes of the bracket, but it is still free to move. One way to define its location is to first select the inside hexagonal face, and while holding the control key, select the outer face of the bracket to create a coincident mate between them. Again, you can use the Flip Mate Alignment option if the mate is backwards. I'll go ahead and delete both of these mates to show you a slightly faster way to mate the two components. I'll select them from the feature tree and press delete on the keyboard. I'll click yes to confirm, and the mates are deleted. A nice technique for adding mates quickly is with something called smart mates. With smart mates, SolidWorks is able to infer certain mates, and even add combinations of mates automatically based on the geometry you select. There is no command on the assembly toolbar called a smart mate. Instead, smart mates are created with a keyboard stroke as you make selections with the mouse. To add a smart mate, I'll press and hold the Alt key as I select the outer circular face of the pin, and when I drag the part, you can see the icon next to the cursor updates, indicating that smart mates is active. I'll release the Alt key, and with the left mouse button still pressed, I'll drag the cursor over the circular cutout. Notice the pin snaps into place, and the pointer changes to indicate the mate type will be created. In this case, a concentric mate. When I release the left mouse button, the Mates pop-up toolbar appears. The type of smart mate created depends on the geometry initially selected. Let me click Undo to show you. This time, I'll press the Alt key as I select the inside edge of the pin. I'll drag it over the outer edge of the circular cutout, and this time, a concentric mate and coincident mate are created in a single step. If for any reason the pin's orientation is flipped, before I release the left mouse button, I can press the Tab key on the keyboard to flip its orientation. When I release the left mouse button, the mates are added. In the mates folder, you can see that both a concentric and coincident mate were added. By using smart mates, I ended up with the same result in less time. A pin that is free to rotate, but otherwise unable to move within the assembly. To keep the pin from rotating, I'll create a new mate to align one of these faces with the right plane. To do this, I'll first turn on the plane visibility from the Hide Show Items dropdown. If you can't see the planes in the graphics area, make sure you turn on the plane's visibility. To do this, simply click the item you want to show, and from the context toolbar, click the Show Hide icon to toggle the visibility on or off. When the plane is set to show, it appears in the graphics area. To create the mate, I'll hold down the Control key and simply choose this face and then select the right plane. From the context toolbar, I'll choose the parallel mate type, and the mate is added. Let me hide the plane by clicking it in the feature tree and selecting Hide. You can now see from the Feature Manager tree that the pin component is fully defined. I'll go ahead and rename this mate to Pin Rotation, and suppress it as well. Here you can see that suppressing the lock wheel rotation and pin rotation mates have limited the degrees of freedom of both the wheel and pin components. If you have SolidWorks Professional or SolidWorks Premium, you will have access to an add-in called the Toolbox, which can be very useful for adding all sorts of standard hardware into your assemblies. You can think of the Toolbox as the assembly counterpart to the hole wizard I showed you earlier in the part design section of this course. It provides a library of all sorts of standard hardware that can be easily added to your assemblies. You can turn on the Toolbox add-in by going to the Options dropdown, Add-ins, and in the pop-up, check the box next to SolidWorks Toolbox Library and SolidWorks Toolbox Utilities. Then click OK. Once the add-in is loaded, you can browse to the Design Library in the task pane, and you will see the Toolbox selection available. If you expand Toolbox, you can see a list of all the different standards that you have available and installed on your machine, including some proprietary fasteners such as PEM and Torrington. For this example, since I'm working in inches, I will use the ANSI inch standard. When expanding ANSI inch standard, you can see a list of the different types of hardware that we can add. I'd like to add hex head bolts, so I will browse to its location, and we can see several different options. I will select the standard hex bolt and drag it into the graphics area and let go of the mouse button to place the component. The Configure Component Feature Manager will pop up, which displays the different properties of the selected component. You should have noticed that the component simply snapped into place when moved to the graphics area. This is a design functionality that is built into special toolbox components called Smart Components, and they have mate references that allow them to automatically be mated with other components in an assembly. Solidworks automatically selects the proper size of the component based on the fact that the holes in the bracket component were created using the hole wizard, so it knows what size of hardware to add. But if you would like to change the size, you can do so by selecting it from the dropdown. I'll leave the default. You also have additional options here in the Property Manager. You can adjust the length of the toolbox component from the dropdown. You can also adjust the thread length. And you can also choose how the thread is displayed. If I look at this hex bolt here, and choose the cosmetic option, you can see that a graphic of the thread appears. Now, the cosmetic thread option is purely for cosmetic purposes only, and it is not actually adding a thread to the part. If I choose the schematic option, this actually cuts the thread into the bolt and is the most realistic, but it is also the most memory intensive. So, if you are using a lot of the same components in your assembly and you don't care all that much about the realism of the threads, I recommend choosing either simplified or cosmetic. I'll go ahead and choose the cosmetic option so that we still have that nice thread appearance without using up too much computer memory. You can add a comment and you can choose to give this configuration a unique name. Solidworks already does a really good job naming configurations. You can see the size, the length, and the C for cosmetic as well in the configuration name, making it very easy to read if you can decipher the code. With the component configured, I'll click the green check and it is added to the assembly. Notice that you are automatically placed in the Insert Component mode, so you can simply click to snap in additional toolbox parts, making it very easy and fast to add hardware. With the 4 bolts added, I can either right-click, click the red X, or press the Escape key on my keyboard to exit the Insert Component mode. And you can see how we can use the toolbox add-in to add standard hardware very efficiently into our assemblies. Another common task in the assembly environment is creating an exploded view of your assembly. Solidworks again makes it pretty quick, and it's fully customizable, as you have your exploded look however you want. To create a new exploded view, you actually have to switch over to the Configuration Manager tab. Right-click the default configuration, and select New Exploded View from the right-click menu. Configurations are a bit outside the scope of this course, but this is the way you add an exploded view. This brings you into the Exploded Property Manager. Exploding an assembly is pretty easy to do. There are a lot of settings here, but more or less you simply select the component. Then a triad appears allowing you to move it. And you can select an axis to move it in that particular axis or in the direction of that axis, in this case, in the left direction. You can then click on the pin component again and drag the correct axis to move it up. Notice that each time you select and move the component, Solidworks adds an exploded step to the Property Manager. You also have the ability to select and move multiple components at once. I'll move these 4 hex bolts and drag the triad upwards. Now the order of the steps will affect how the exploded view looks when you animate it, because you can animate the exploded view to collapse and expand. One of the options that I want to go over is the Auto Space Components on Drag option. This is really useful with hardware stack-ups such as a screw, nut, and bolt. The rest of the options for creating an exploded view are a bit more advanced for this lesson, so I will not be going over them here. Once completed, I'll click on the green check to create the exploded view. Notice that right now the assembly is just in its exploded state, but you cannot see anything unique in the Configuration Manager. To view the exploded view, I'll expand the default configuration, and from there, I can expand the exploded view to see the different explode steps that were created. To return the assembly to its assembled state, you can either double-click on the exploded view configuration to toggle it on or off, or you can simply right-click the exploded view configuration and select Explode or Collapse. And like I said earlier, you also have the option to animate the exploded state. This brings up the animation control box, where you have your typical play, rewind, rewind to start, fast forward, and etc. You can play the animation over and over. Also, you have an option to save the animation as an AVI onto your computer. If you close the control box, you can also animate the collapse state by right-clicking on the exploded view configuration. This brings up another animation control box with the same options as before. Animating an assembly is a great way to create instructional videos on how an assembly can be put together and can be very easy to do. As I mentioned earlier, Solidworks also allows you to create something called subassemblies, which is simply inserting an assembly inside of an existing assembly. Here, I have a simple base plate part that I've created with a few mounting holes in it, and I'd like to start a new assembly from this part. I'll go ahead and select the Make New Assembly from a Part or Assembly option, which brings up the Begin Assembly Property Manager. I'll insert the base plate component from my list of open documents, and click on the green check to align the origin of the components with the reference of the assembly. Next, let's insert our wheel assembly by clicking on the Insert Components icon. Select the subassembly, drag it into the graphics area, and simply click to place it in the desired location. To insert a copy of the wheel subassembly, instead of using the Insert Component tool, I can hold down the Control key and drag additional parts and assemblies into the graphics area from the Feature Manager. This is a very quick way to insert 3 additional instances of the subassembly component. One of the advantages of using subassemblies is that these components already contain the mates that were used to create them in the first place, making it much quicker and easier to insert into this higher level assembly. I'll launch the mate icon, and I will create a concentric mate between one of the edges of the holes and one of the edges of the base plate. I can then repeat this for the cross corner. Again choosing a concentric mate type. And finally, I can add a coincident mate between the bottom face of the wheel subassembly and the top face of the base plate to add this part in its desired location.